Hello everyone, welcome to my YouTube channel. My name is Precious. In this video, we're going to look at the concept of multiplication and division under calculations using logarithms. So you recall that we have seen how to find the logarithm of a number and the anti-log of the same of numbers using log tables. All right. So here we now want to see how we can apply those principles, in multiplication and division of numbers. And this particular arithmetic make use of the basic principles of, indices. For instance, if I want to do 2 times 6, sorry, 2 times 3, this is simply equal to 6. Of course, this is very easy because it is the small numbers and they are whole. But when you have decimal numbers, it is a little bit more tedious. Now, however, you can see what this logarithm will do for us here. What is the principle here? Is just only asking us to do, you recall in indices we are told that if you have x raised to the power of a multiplied by x raised to the power of b, that this is equal to x raised to the power of a plus b. Okay, so what this logarithm approach does for us is that it takes, remember I told you that the logarithm of a number, for instance 2, especially the common logarithm, which is what we are doing here, is the power of 2 in base 10, and it is actually approximately equal to 0.3010. Okay, and then if you find the logarithm of 3, you are going to get 10 raised to the power of 0.4771. This is the approximate values of the logarithm of 2 and 3. So by the time you now apply this rule of indices, the bases are the same now. So this is simply going to give you 10 raised to the power of the sum of these two. You are going to get 0.7781. Okay, so and that's what you have. And now if you want to find the value of this particular index number, remember I told you in our previous video on logarithm that this simply means you should find the anti-log of the power. And if you check your four-figure table and you look for the anti-log of this, you are going to be getting something that is approximately equal to 6, which is exactly what you get when you do this multiplication. That's the basic principle that this arithmetic depends on. So it uses the principle of indices, and even for division the same thing holds. Assuming this was a division here, so what will happen is that you are going to now have that this is equal to 10. You recall that under division, if I have x raised to the power of a divided by x raised to the power of b, the rule of division says that this is equal to a minus b. And so if you do this subtraction, whatever you get here, you will now take the anti-log of it and you will be able to get the value, which is your 2 all over 3. Right, so let's see these examples. It says we should use the tables to calculate the following. So we'll begin with example 1. I'm going to draw my log table. Okay, so on my log table, I will have number and I will have log. So I'm going to write each of the numbers I am multiplying. So I have, okay, so when you have done this, the next thing you need to do is now to get their logarithms. So we are going to get the logarithm, and to get the logarithm, we need to get the characteristics, and the characteristics of each of them is 0, because the number before the decimal point is 1 digit, and so 1 minus 1 is 0. So I'll have 0 point. Now, so I'm going to look for 24 under 1 difference 3. 24 under 1 difference 3. So let's quickly look for that. Okay, so for 24 under 1 difference 3, this is under 1 here, and my difference 3 is 5. So if you add it here, you have 3825. Okay, so let's go back here. So we have gotten 3825. All right, and then by the time I now look for the other one, the characteristics for the second one is also 0. So here I am looking for 30 under 9 difference 2. Okay, so let's go to that. 30 under 9 is this, then difference 2 is 3, and that is 4903. Okay, so we come back here. So I'm going to have 0.4902. Okay, and so after you've gotten the two logs, the next thing now is to add the both of them. And if we add, just like what I did in the previous slide here, when you get the two logarithm, if it's multiplication, you add the powers. Okay, so I am going to be adding the logarithms which serve as the powers. So here I will have 7, I will have 2, this is 7, we carry 1, and then we have 8 here, point 0. Okay, so that is the value of the sum. And so the next thing now is to find the anti-log of this. And by the time I find the anti-log of this, I'm going to write my solution on this other side. Okay, so let's quickly get the anti-log. And that anti-log is actually the solution that we are looking for. Okay, so the anti-log, we are going to look for anti-log of 0.87 under 2 difference 7. Okay, so this is 0.87 under 2, then difference 7 is here, which is 12. So when you add that to this, you're going to have 74, then 19, sorry, 7459. So that gives us 7459, and then we try to now bring back the decimal point. And if you bring back the decimal point, you just add 1 to the characteristics, which will give you 0 plus 1, and that is 1. And so you count the first digit and then you put your decimal point. So what that means is that the the value of our 2.1413 multiplied by 3.092 is approximately equal to 7.45 and 9 approximately, and that is our solution. Okay, so you take over the process again, write the numbers you're multiplying, and of course here is multiplication. So you get their logarithms, you add them, you get a solution, a value. Look for the anti-log of that value, and that is your solution. If it is division, you will subtract. Okay, I'm going to do this example 2 and then 3, and I will allow you take on example 4. So for 2 we have 705.6 multiplied by 8504. Okay, so we will draw our table. Okay, so what then is going to be the mantissa of the two of them? So to get the mantissa of the first one, we are looking for 70 under 5 difference 6, 8486. Now for this other one, 85 under 0 difference 4. So here I have 92 and 96. Okay, so the next is to add up what I have. Okay, so now we are going to look for the anti-log and we'll write it on this side. So the anti-log of 0.77 under 8 difference 2. And then we have our 6001. However, where will our decimal point be? We have characteristics of 4, we add 1, that's 5. So we count 1, 2, 3, 4, and then the fifth one, we complete it with 0. Hence, it means that our 705.6 approximately. Remember that each of the values we are getting from this is the approximate values, because of course these values are approximated to 4 decimal places. All right, so that is for the second example, and let's look at the third example and see what it gives to us. All right, so for example 3, we have 912.4 divided by 53.55. So what are we going to do? We will try to get the logarithm of the two. And so we'll try to now sum what we have. Okay, so to do that sum, we are sorry, because this is division, we are not going to sum, rather we'll subtract. You remember that. So 2 minus 8 will give us 4. We borrow 1 from here, and we'll have 5. Put 1 here, that's 9. Then this is 12. 12 minus 8 is 4. 9 minus 8 is 1. 5 minus 2 is 3. Then 9 minus 7 is 2. So we have point here is 1. So now we are looking for the anti-log of this value, and that is 0.23 under 1 difference 4. So we got 1704 here. All right. So we'll now need to find the position of our decimal point. And since the characteristics is 1, we add 1, that's 2. So we count the first 2 digits. And what it means is that the and that is the solution to this. So, and like I said, I'm going to allow you to look at the example 4 and see what you will do with it. And let me have your solution in the comment section below. That is 43.14 divided by 8.932. Of course, this is where we'll end it for this video. And in our next video, we are going to see how to also resolve powers and roots using the logarithm table.